friends, in our last session we have started with strategies for user intervention in cyber-physical system. We have seen certain topics related to that. We have seen two types of cyber-physical system which exist in our industry, that is fully automatic, and second we have seen user-driven CPS. We have seen the example for both of them. Now in today's session we are going to see the processes for a user intervention in CPS. Along with that we are going to see advanced manufacturing innovation ecosystem. What is that? We are going to see the introduction to advanced system. This is Fazan Kagdi and I welcome you all to our lecture series of Industrial Internet of Things. So let's begin with our topic. Okay. So we have to understand this diagram. Now this represents a process for user intervention in cyber physical system and in supporting services. So there are basically four steps involved in this system. The first step is to do a selection of a target element. As we have discussed the CPS segment, right, in our last session in an example. What is the CPS segment? So CPS segment defines the target for a user intervention. Okay, that is for a human action, it defines the target. That which part of a CPS or which elements requires the human action or human involvement. So that is our first task, that is selection of a target elements. Now this could be a cyber physical system, that is cyber physical elements or a supporting services, right? In our last case we have taken an example. In that, elements were 3D printing machine, then printing machine, and storage and retrieving a retrieval machine, right? And supporting services were change product application and monitoring services, that were our supporting services. So these are the target elements for a CPS. Remember this. So this is the first step. Second step is a preparation for a user intervention. Okay, which means we need to prepare that what change a human has to do in a particular system or a particular element. What a element is facing a problem, which problem is present in an element, that we need to determine, and as per that human intervention has to be done, right? So over here you can see a box is shown. So how we can do that? Now there are two possibilities to do a user intervention. First of all, we can deactivate the entire CPS element. Okay, so deactivation task would be required, or else we can take a snapshot of the CPS element where it faces the problem, which means a snapshot will contain all the informations regarding the problem so that it can be utilized for a user intervention later on, right? So it is going to include the CPS behavior adjustments. Now that could also include the user interface description, then configuration parameters, scripts, and end user development. So all these basically are the components or the scripts in which a cyber physical element could face a problem. Okay, that is a description or a programming is not proper or end user development of a API is not proper. So that snapshot has to be taken and further user intervention can be done. So third step is the user intervention. Now as per the snapshot, we would say user is going to give a command to the element or going to troubleshoot all the problem which is present. Okay, next step is a deployment of a user intervention. So in this step we would say that whatever intervention or action is taken by the user, that would be taken as an input by a cyber physical system. Okay, now the cyber physical system is going to check whether the input or a solution which is provided by the end user is correct or not, whether we can apply that solution or not. That validation will be done by the system itself. If that validation if that change is correct, or if it validates the correctness, then cyber physical system is going to deactivate the target element. Remember, it's going to deactivate the target element, and whatever changes which are done by the user will be implemented to the target element. Okay, which means the deployment of the changes will be done inside the element, and after that that CPS is going to finally activate the target element of a user intervention, and finally the change has been accepted. We can say that. So this is a whole process, starting from a selection of a target elements, then preparation of a user intervention, the user intervention, that is a change which has been done, and finally deployment of a user intervention which is done by cyber physical system. Okay guys, so I hope that you are clear with this process. Remember, this diagram you have to draw to explain the process of a user intervention in cyber-physical system and supporting services. This entire diagram starting from the selection of elements till the deployment of a user intervention has to be explained. So now let us see the next slide. Now in this slide I have explained whatever I have explained is mentioned in this slide. All the 4 steps are explained in detail starting from a selection of a target elements to the deployment of a user intervention. Remember the steps which are there: selection of target elements, preparation of user intervention, and finally deployment of a user intervention. So whatever I have explained is covered totally. So it's all completed. Now let's move on and see our next topic. Okay. Now next topic is our introduction to a advanced manufacturing innovation ecosystem. Now, advanced manufacturing is essential for developing new products and processes across a range of industries, both established and emerging. Which means that we need to do a advanced manufacturing. That is, we need to install a cyber physical system. We need to install IoT based system. Okay, within our factory. Okay, so these two, that is cyber physical and IoT combined, is going to contribute or make the factory as a smart factory and the manufacturing as a advanced manufacturing. So definitely it is essential for developing a new product and processes across all the ranges, both in established industry as well as in a developing industry, that is called an emerging industry. Okay, now there are basically two types of factories or industries classified as SME and OEM. So SME is called as small and medium sized enterprises, and OEM are called as an we would say original equipment manufacturer. Now, if we consider a simple case example, that if an enterprise or a company has employees less than 500, so that company is recognized as a SME, small and medium sized enterprise. And if the employees of a company are more than 500, okay, and they are developing innovative products, they are directly connected with the startups, or we would say new products which are developing, so that large enterprise are called OEM, that is original equipment manufacturer, and these have employees greater than 500. Okay, so this is the main difference which we need to remember. Now as you can see in the second paragraph, that small and medium sized enterprise plays a critical role in maintaining and growing the manufacturing strength. Okay, in most of the cases you will observe that at different places we have small and SME are more. Okay, and OEM are comparatively lesser. Why? Because they are going to produce an innovative products, right? So SME are going to contribute more to the economic development of a country, right? So it is going, that is why it is written, it is going to play a critical role in maintaining and growing the manufacturing strength. Okay, these companies are the backbone of countries and regions industrial capabilities, and they exist in every community where manufacturing takes place. Now even we can say that SME, that is a small and medium sized enterprise, is going to supply to the large firms. They are going to supply smaller components, or we would say some parts of a product which are required in a manufacturing of a product by a large company will be supplied by these small companies. Okay, which means SME again plays an important role as a supplier to the large manufacturer. Okay, that is a OEM. So that regularly develops the sophisticated products and systems, and entrepreneurial firms that engage in prototyping or pilot production to advance a new product. Okay, so I hope that you are clear with these two paragraphs of advanced manufacturing innovation ecosystem. So let us understand the key terms required for advanced manufacturing. So the first main term is IoT. Remember that IoT is a global infrastructure which is required, Internet of Things. And second requirement is a cyber physical system, that is basically an embedded system. Okay. So let us understand what is IoT, what it comes under that. So IoT, Internet of Things, is a global infrastructure enabling the advanced services by interconnecting physical and virtual devices based on existing and evolving information communication technology. Whereas what is CPS? So we would say that cyber physical systems are the embedded systems that are connected to each other using a digital network. Now we already know about the embedded system. If you remember, I have given the idea during our first session, that is embedded system is basically a microprocessor based system in which there is a microprocessor hardware with a software, and to together they are going to perform a dedicated function. Okay, a task is performed. So that system is called a embedded system. Basically, we can even say that embedded system uses a microcontroller. It uses a microcontroller which takes input from a keyboard or a button or any other sensor and provides output in a form of a display or by running the electric motor or by doing some mechanical work. So the best example is a washing machine. Okay, washing machine will be called as an embedded system. Remember, similarly, there are several devices. I'm going to give the example. Now, how I can say washing machine is an embedded system? So we know that fully automatic machine has a buttons provided, right? You would have observed a rinse button, right? A spin button, a timer button, for how many wash we need to do that. So what we are doing, we are actually pressing that button. Okay, there is a fuzzy logic or a microcontroller which is present in a washing machine. Now when we press this button, we are giving input to the microcontroller. Okay, now that input will be converted and it is going to give an output in form of what? So running the electric motor, which means a drum of a machine is going to start to rotate. A best example, that is a mechanical power will be generated, and how much time will be taken by a machine to finish that clothes will also be displayed on a screen, which means a display is given, right, and output has been started, that is a drum is started to rotate to wash the clothes, right. So this is the best example of an embedded system, that is a washing machine. Similarly, we have another example such as we can say a remote control, right, a traffic control system, a patient monitoring system, right. We have seen that, then light sensors, then dishwashers, right. So all these are the examples of an embedded system. Remember, there will always be a microcontroller present in an embedded system, or we can say that 98% of microprocessors produced are for the embedded system. Now there is a main difference that these microcontrollers are going to consume less power compared to the computers, because computers are capable of doing a high processing task, whereas microcontrollers performs a low processing task, and also the storage capacity of these microcontrollers is quite lesser. So that is called a embedded system, and we can say that our CPS is what? A CPS is our embedded system. We can take several examples of an embedded system. Also, we can say a microwave oven is an embedded system, MP3 player, right? Then video game console, right? That we know that PlayStation. So all these are embedded system. Again, we can take an example of a printer, that is Wi-Fi enabled printer. So these are all the embedded system. Now this is going to be provide a connection to each other by a digital network, which means for connecting all these systems or embedded system, we require internet, that is IoT. So two things, two requirements, two key terms. That is, first is IoT and second is a cyber physical system. That is, an embedded system is required for advanced manufacturing. So I hope that you are clear with these two key terms. Now in the next slide, I have taken a diagram. So over here you can clearly see that IoT is required for advanced manufacturing and cyber physical system is required. Now what is IoT? So IoT is an industrial internet. And what is the cyber physical system? So it is an embedded system. Now, what does IoT provide? So, IoT provides an infrastructural requirement, and what does CPS provide? So, CPS provides a technical requirement. Together, we would say combining both of them is going to result what? So, it is going to result Industry 4.0, and that is term is called a advanced manufacturing. And the result of this Industry 4 will lead to our factory into a smart factory. Very simple, guys. Okay, so I hope that you are clear from this chart. So, this smart factory will be called as a smart manufacturing. So remember, both IoT and CPS are the infrastructural and technical requirements respectively for the proclaimed fourth industrial revolution, or we can say Industry 4.0. Okay. So now over here you can see that a term of advanced manufacturing has been explained. That is, advanced manufacturing refers to the use of a next generation technologies in a manufacturing process. It makes extensive use of a computers, high precision and information technologies integrated with a high performance workforce in a production system capable of furnishing a heterogeneous mix of product in a small or a large volume with both efficiency of a mass production and a flexibility for custom manufacturing in order to respond rapidly to the customer demand, which means we would again have a information technology, then a high performance workforce, that is the humans which are highly capable, highly skilled. Along with that, by doing so we can produce a vast variety of products, that is heterogeneous products in a large volume or in a small volume, and in a mass production, right? And even we can do this by fulfilling a customer demand. Okay, even customer modification or feedback can be utilized to modify the product. So this can be done in case of an advanced manufacturing. Now let us move on. Now this represents the innovation fields. So there are four types of innovations which are required in a factory: product innovation, process innovation, organizational innovation, and service innovation. A product and service innovations which is done within a company would be a first time commercial utilization, and that product and service innovation could also be new to the market. Okay, which means there is not so this type of innovation are not actually present in a market, that are developed by a company as well as it is new to the market. Whereas whenever a process innovation takes place, so process or method are already available in a market. Okay, different methods are available, so there are chances that whenever a company implement a process, so that process could be new to the company. For that company, that process will be called as a process innovation, but in actual case that process is not new to the market. That method is already existing in a market, which means other companies are already using that. But when one of the companies implementing that process, so that is called a process innovation for that particular company. Okay, for example, Six Sigma. So some of the companies using a Six Sigma technique, some of the companies not using a technique, right? A lean manufacturing technique. One of the companies using a lean manufacturing, another one is not using. So the one which is not using, and if it is implementing that technique, so we can say that it has done a process innovation. This would be a process innovation for that company. Okay, so it is written over here. Now further organizational innovation. So it is an implementation of a new organizational method within a firm that changes the firm's business practice, communication, and workplace organization. The latter two innovation dimensions have a clear company perspective in following. The primary focus will be on a product and process innovation. So the company's primary focus will always be on a product and process innovation that has to be done continuously. So from this diagram, we can even say a tangibility is shown, and over here an innovation object is shown. Now, if you consider this, when we move towards the right side, that is an organizational innovation and service innovation. So these are intangible. Okay, intangible means these are not visible. We cannot feel. Okay, but there is a change, which means the change in an organization has taken place. Okay, but we cannot touch it. That is not a physical change. Okay, so that is called an intangible. We cannot measure. Whereas when a process innovation or product innovation is done, so that is a physical change. Okay, that are tangible. We can touch it, we can feel it, right? We can see that innovation. So that is called a tangible. Okay, guys. Similarly, a process and a product. So on a top side, we can say a product innovation is done on basis of object. On our bottom side, there is a change in a process has to be done. Now let us move on and see the manufacturing innovation system which has been accepted in Massachusetts, that is in Boston, America. So you can clearly see that the companies which are shown: SME, small and medium sized enterprise, OEM, original equipment manufacturers, then startups and universities. We have to understand this diagram very clearly. Okay, guys. Now observe carefully in this diagram. You can see that links are connected and arrow is shown. Over here it is clearly mentioned that this arrow which is shown by a thick line, it is a innovation sources. Okay, then a thin line represents a weak knowledge flow, and a thicker line represents a strong knowledge flow. Okay, so we can say based on a research, four key nodes and associated institutions plays a major role in an advanced manufacturing innovation system. Remember, now you can clearly see on all the four sides there is a R&D network. On a one side shown, on a top side association is shown, on a left side there is a global network is shown, and on the right side through the universities there is a R&D network is shown. So these are basically the innovation sources which are providing new ideas to these key nodes. Now let us understand and start with OEM. So you can clearly see that OEM, original equipment manufacturer, have a strongest link within a network. You can see they have a strongest link with SME for a knowledge flow. They have strongest link with the startups. They have strongest link with the universities, which means that OEM are capable to provide the knowledge to these three components, that is SME, universities and startups. As well as startups are going to provide innovative ideas to OEM. Why? Because OEMs are going to produce an innovative product, but some ideas are already required. So the startup company is always going to provide a new idea or new innovation to the OEMs. So we would say there is a strong knowledge flow from a startup towards the OEM. Okay, and from the OEM, the knowledge flow is taking place to the SME and to the universities. Now, in case of the universities, the knowledge flow is in a both directions. That is from a OEM to the university and from a university to the OEM. Okay, guys. Now, in case of a SME, as you can see that SME has a weakest link within the ecosystem. Okay. Now, historically, they have most often been on a receiving end of a knowledge flow from a large customer. So, as you can see that OEM, that is the original equipment manufacturer, is going to provide a knowledge to the SME. Okay, this is on a receiving end. Whereas SME is not capable of providing a knowledge to OEM. There is a weak link is there. Similarly, SME is not able to receive knowledge from a startup. Why? Because startups are always going to contact the large manufacturer. They are not going to contact the smaller or medium sized enterprise, which means over here you can see a weak link is shown from a startup to the SME. Similarly, university is again not going to directly contact the small enterprise. Why? Because they require a large or a bigger enterprise. So they are going to do a strong knowledge communication with the OEM. Okay, guys. So again, SME is only capable of receiving the knowledge from OEM, that is original equipment manufacturer. Now talking about universities. So universities have a strong link with OEM as well as with the startup, which means the knowledge will flow from a university to the OEM. Okay, whatever new technologies has been developed, that would be discussed with OEM as well as with the startup communities. But they are least bothered to discuss that with a small and medium sized enterprise. Okay, guys, so that is discussed in the next slide. That is, universities have relatively strong link with a large OEM with a startup community. Now, finally, the vibrant startup community. Now, let us talk about startup community. So, obviously, that a startup community is going to reach to a large manufacturer, that is our OEM, original equipment manufacturer. Why? Because they are capable of producing the innovative product. They are going to take a risk to produce a startup product, right? So, the strength of a link between a startup and OEM depends in a part on an industry and on an extent to which OEM is open to accept their innovative ideas, which means definitely it depends on OEM whether to accept the idea or innovation provided by the startup or not. So startup are highly dependent on this OEM. So this is what represents the innovation ecosystem in Massachusetts, that is in Boston. In India, such type of innovation is yet to occur or to take place. I hope that you are clear in today's session. So with this, we are going to complete with our chapter, that is evaluation of workforce and human machine intervention. In our next session, we are going to start with a new chapter, that is application of IIoT. So till then, stay tuned and thank you all.